Okay, so let's start today's lecture. Let's have first a small plan for the following days. For the following weeks. Today we will, in the beginning, see the theory part of the authentication. Then, in the next hour, we will implement the authentication part on the server side. So, this is for today. Then, next week, in the first hour, we will see the authentication on the client side, so all what refers to React. And then we will start the exam simulation. So we will have a first hour on the exam simulation here on the 27th of May. Then, last lecture, obviously there will be the laboratory on the authentication part. Then our last lecture together and the last lecture of the course will be, again, we will have here another hour and a half on the exam simulation. And the last hour we will dedicate it to question about the exams. So, also related to the exam text of the first call that will be published, I think, about the 30th of May. So here we will discuss about the text. If you have questions in general about the exam. Okay? Do you have questions about this agenda? Okay. I just want to say that we will have this small exam simulation. I don't think that the hours that we have will be enough to cover all the to code all the application, but at least, well, we have seen up to now, we have developed the two applications, the one in classroom, the other one, I look there because it is easier for me to look there, you choose, so it is not something related to you, but it is easier to look there. And then, so we have developed the application during the course, and then you have developed your application, the one that you choose in the laboratory. Then we will see how to, and all the design choice that you made along the development of the application during this semester were, I think, made based on what you knew at the moment. Probably there were some design choices that you would have made differently if you know all the whole structure. So we will see at the end how, with all what we know, how to start the development of the application and then for the exam. Okay, so first objective of today, let's see the theory part of the authentication. This is a lecture that nobody likes, okay, so you see, and the whole structure is quite complex because you should consider all the security matters, but luckily there has been some guys that have developed libraries that we can just plug in our code and everything works well. And I hope that also for us today will work everything well. So clearly, for this this theory part, we will see why we need authentication. I mean, and then HTTP session and the authentication reactor, so on the client side, and Express with on the server side. So, first thing, we have to understand the difference between authentication and authorization. They happen in 2 different times. So let's see. The authentication is when we verify, if the user is who he says to be. I mean, so the user says, "Hi, I am Francesca, and this is my password." Okay. Now we have to verify that Francesca is exactly Francesca and not Luca. Okay. Obviously, the authentication is I don't know how to define it, but it is a concept that has several layers. I mean, we can, I can trust you if you say me, okay, I am Francesca. I can ask you to show me my, your identity card, and this is a more secure kind of authentication. Then there is, I mean, also that can be fake. So the only way to exactly verify the user is actually do like a DNA test. But I mean, this is not this is not the case. So what we are going to do is an authentication based on the username and the password. This happens at login time. So at login time, we verify who the user is and if it is true what he says. Then we have authorization. Authorization happens throughout the application. If there are some actions that the user A can do, other actions that user B can do, and so we have to differentiate what each user or a group of users can do throughout all the application. As said before, the authentication can be quite complex, and if we want to develop it from scratch, it can be difficult, time-consuming, and of course we can do some errors that we may not think about. I mean, there has been a lot of attack of security during 30, 40 years. So there are some very nice people that putting all this together have developed something. So thank you guys, and we just plug in and solve all our problems. Obviously, there are some authentication that may require some third-party interactive, so the authentication with Google, Facebook. We will not cover these. I will show you the hint to how to not use it, but how you can find it. But we will not cover these in the course. Okay, so where happens authentication? Authentication and obviously authorization happens throughout all the application and throughout all the layers that we have put in our web application. So let's see. I don't see my mouse. Okay, it is here. Okay, so we have for sure the user at the beginning, and then we have to verify if the user is logged in, and so that we can authorize the user to do some action throughout the application. Then also the browser itself plays a very important role throughout this part, so especially in the authorization. So it is kind of involved in allowing the user to do certain action, and we will see better how it happens. Then we have the server that obviously has to remember the session data, so it creates the session ID and remembers the user information associated to the session ID. Obviously, the session ID will be created at the login phase and destroyed at the logout. And it will be retrieved at every HTTP request. I mean, I think that this slide could be seen after, but probably what we can do is to re-watch it at the end to verify and fix all the concept. Then we have the root, so the HTTP APIs that check the authorization and verify the session validity. Obviously, the special root to perform authentication, and finally, obviously, the database related part that verifies the password, if the password inserted by the user is correct at login time, and then queries the session information at each HTTP request. Okay, so let's see what how all these work and why we use cookies and sessions. HTTP was invented as a stateless protocol, and actually just after some years or probably less time, they released the second version, HTTP 1.1, that includes the cookies. Why? Because a web application may need to keep different information across different interactions. So, what is a session? A session is an abstract concept that actually contains remembers the user information, so who you are or other information according what it is needed to store. Okay. Then, how the session, how all these is kept. So all these is kept thanks to the session ID that is created at login time, and when the user authenticates, the client receives a session ID that should be random enough to not include any information about the user, so not any information about the password especially, and it should not be stored on the server side, on the client side. Actually, what happens is that the cookie will be stored in the cookie will recognize will help the server to recognize a specific session. So what happens is that the cookie is related to a specific browser and a specific user, so that when we should be sure in a certain way that when we receive a query by a certain when we receive a certain API and there is this cookie, we should be sure that this comes from this browser that is being used by this user. As I said before, the cookie is automatically handled by the browser. So when we perform an API request, the browser automatically inserts the cookie inside the headers of the APIs. Okay, so the cookie is created at login time by the server, and we have some different attributes to set. The name of the cookie, so this one. Then we have the value that should be again a string, random enough to not really reveal any information. Actually, it should not contain any information about the user, but it is just a string that on the server side will allow the server to retrieve the information about the user. Secure if is a flag that will see if that will say that the cookie will send only on HTTPS connection. We will not do this. We will just do HTTP only. Obviously, when we are in production mode, we should use HTTPS connections. Finally, okay, other two attributes, the HTTP only, that it is again a flag, and if it is set, the cookie will not be accessible by JavaScript code. So this means that the cookie will never be stored on the client side. And actually, this is what we will do. And then an expiration date. So it can be set to 10 minutes, 1 hour, 10 days, and when the expiration date comes, and we will send a post, for example, and we say to the server, okay, I want to post to modify this data with this cookie. The server will check this cookie and see if it is still valid. If it is not valid, the server just answers, okay, the cookie expired, unauthorized. So you cannot perform your action, your post, your get, or whatever it is. Okay. Okay, so we have the browser here that performs a post at login time with the username and password. This post is sent to the server that saves the information about the session. That is the session ID, that is actually the cookie, then username, all the user info, whatever it is actually needed. and then sends back the cookie. That is actually again the session ID. Then at this point the user is authenticated. This part here is related to the authentication. Then let's see how the authorization part works. Here we have the user that does a get exams, and the browser automatically inserts the cookie, so the session ID, and sends this get to the server. The server on its side receives the get and checks the session ID to retrieve the session data. So checks if it is valid, if it is not expired, if it exists first, then if it is not expired, and so on. And then if the user is authorized to do that certain API, so to request the exams in this case, answers with the exam content. Okay, so again, as I said before, we should use HTTPS and secure part of cookies, but at least in production here we will see only the HTTP part, and we should rely on what already has been invented, so we should use the libraries. Just because, I mean, we don't want to reinvent what has already been done, except if we are not, if we are researchers, but here we are not doing this. Okay, so let's see in practice how the authentication works. Sorry. Okay, let's see the flow to see how all the authentication and authorization happens. We have a form where the user inserts the username, its password, and obviously we can add a small validation on the client side, such as if the first field required is an email on the client side, we can check if the user has actually inserted an email, if it is in the correct format, and so on. Then we pack the post and we send to the server. The server at this point receives the request and checks if the user exists in its database, so if the user has already registered, or and if the password matches. If not, so if the user doesn't exist in the server database, it answers with the wrong username and/or password. Again, for security reason, we should never say what is wrong, if the password, if the email, otherwise if we know that if an hacker knows that only the username is wrong, he can think that the password exists, so he can check, for example, the users on that server, and with a brute force attack, guess a username and password combination. Then, if the username and password are correct, at this point the server generates a session ID. And that is stored on the server side with some information of the user that are retrieved from the database, and it will be saved in a storage that is dedicated to the session's ID. At this point, the server replies to the HTTP request sent by the browser, creating and sending a cookie with the session ID, the name that is session ID, the value that is the generated string that represents that session, and all the other attributes that we have seen before. Finally, the browser receives the response with the cookie that is automatically stored inside the browser, and this then can be used by the client side for presenting something to the user. For example, we can receive from the server that in an information such, okay, this username and this password corresponds to Francesca, and on the client side we can say something like, welcome Francesca to our beautiful, very nice web application. On the client side, there isn't very much complex. I mean, we have just to create a login form with some validation, as I was saying before, to check if the format of the email is correct. This is done with the classic useState, and then we have a useState action version. I think that you should use useState action. And then let's see how it is done in practice on the server side. That is mostly what we will cover today. What we are going to use is obviously Express and an additional middleware that is given by Passport. Let's see it. I don't remember if I already opened it. No. So. Okay, very simple. It is not well documented, so professors before me tried to put together a very good slides to present you in the best way. So let's see. We have the iLibrary authentication middlewares for Node.js, and there are different strategies. Here we can see. Here, for example, we can use these for authenticate through Facebook, Google, Twitter, authentication with 2 factors, and GitHub. I mean, there are all kinds of strategies that you may want to use, but here what we are going to do is just to use a local strategy. So we will just use the username and the password. Okay. I mean, we have just to install Passport and Passport local, and here we will see the strategy, and so on. Okay. Let's see. we have to configure the server to use a Passport for the authentication. It is quite easy. It is just a matter of copy and paste certain function in the right point. What we have to do is to first choose the authentication strategy that in this course we will use the local strategy. Then we have to add additional middlewares and decide which user is linked with the specific session, but this we will see better after. Let's see how the local strategies work. So this supports the authentication with the username and password. We have to install obviously Passport local, and let's see how it works. We have to define a middleware with the local strategy that receives a function verify. What does this function is to verify the username and the password. We just calling a function that receives a username and password and verify. And then in this function we will actually define how the username and password are actually correct or not. And then we have a callback. That is the function that is called after the authentication. So the callback indeed gives to Passport the information about the authenticated user. So if the user is not authenticated, for example, it doesn't exist, or the password is wrong, or the mail is wrong, it will return null false. Otherwise, if everything went well and there weren't errors, the callback returns null and user information. Okay, it was explained here. So we will have null user if we have the valid credentials. So again, username and password, everything correct. Null false with an optional message error. So the invalid credential with an explanation that again it should be it should not be specific about what is actually wrong. If it is wrong, the password or the username. And then there are other two cases with just an error message or the what we will use is actually the null user with valid credential and null false if the login failed. Then there are two other ways with adding a message or only returning a message. The user is an object user that will contain only the information that we retrieve from the server that we want to send to the React application. So if we want just to send the name, the user object will just contain the name of the user. Obviously, on the server side, we may maintain more information about the user, but at this point we just decide which information we want to send to the client. Then, how do we store the passwords on the server? In clear, no, we are full, we cannot store the password in clear on the server. So what we will store on the server side is an hashed password, so or better, a salted password. I don't know if there is something that that studies cybersecurity here. Yeah, you may be more, you may be better with respect to me to explain this. What we do is to create a string that is the salt. The salt is put it together with the password, and then all this is hashed, and then we will save this hashed password on the server. On the server, we will store this hashed password and the salt that has been used to create that string. Correct? Okay. Sorry? Yeah, I mean, in the basic form, it is something like this. And to do this, obviously, we will not do it by hand. We will just use the crypto module because we are not full. We don't implement anything from scratch. We just reuse what some very nice people did for us. Okay, so there are two main passwords, two main functions that we will use. They are both async and they both return a promise. Crypto.script. This is to generate the salted password. And what it receives is the password in clear, the salt, that should be a random string, and the length that we want to obtain, and we can call the function that receives a callback, sorry. Then the other function that we are going to use is time-safe equal, that check if the stored password and the hashed password are equal. Why we use timing safe equal instead of just comparing the string? It is again a security matter. Does anyone want to try to answer to this? Okay. If we compare two strings, the function returns when the first character is different, okay? So if the first character is different, it immediately returns. So an hacker could check, okay, so this is different, so it is not right, we'll go checking the next one. And so with many tries, he can identify all the correct character one by one. So we use time-safe equal that guarantees, at least it is what they say, that all the checks are done in an equal time. Okay, so let's see how this inserts in the verify function for Passport. Again, it was this function here. Okay, okay. Here, when we define our strategy, we call here a function getUser, to which we pass the username and the password inserted by the user. Let's see what this function does. Obviously, it returns a promise that because it is we are doing a query to the database, so it is an asynchronous function. We define the SQL function that retrieves the user information with a specific given email. And then we check. If there has been an error, we reject. Obviously, this could be a database connection error and so on. Else if the row is undefined, what could be the case in which the row is undefined? It can be when the user doesn't exist in the database. So if the user doesn't exist in the database, result false. Otherwise, let's see here. We construct the user object with the row ID and the email. Then here we extract the salt that has been saved on the database and create the salted password with the function cryptoscript, in which we pass the password, the salt, the length of the hashed password that we want to obtain, and it should return the hashed password. And we check again if there has been some error, we reject, otherwise we check if the row.password, so the salted password that we have saved in the database, is equal to the hash password that this function has just generated using the password inserted by the user and the salt extracted by the database. Then, okay, then there are some additional things that we have just to use to configure the server. Okay. So we have to configure our application to use session in which we define a secret that is a secret phrase of choice that it can be any string that you want, and this is actually the only attribute that we are going to use. And then we have to init passport to use session. Okay, as I was saying, the secret that is used to sign the session ID cookie. So again, as I was saying 20 minutes ago, probably, we sent the post to perform the authentication, the server checks, does all what you want to do, and then it generates a cookie, and the secret here is used to sign the cookie. Okay. After checking if the user exists, has inserted the correct password and so on, we have to define two functions that are required by Passport to serialize the user and serialize the serialize. The first one is the serialized user that creates an object, a user object, that can be sent to the client side. So in this case, we are just sending the user ID, the email, and the name. The nice thing that I probably was forgetting to say is that with this serialized user Pax creates a user object that then will be available throughout the application. What we can do after this, in any point, we can check like request.user or .session.user, and it will and the user information will be available in any point of the application. Then we have the deserialized user that again just returns the user information to the request that are exactly the same information that have been serialized before. Okay. Then what we can do after we have set everything on the server side, we have to add an express route to perform actually the login. What we do is define the route. We add a middleware that says how we want to authenticate, so the strategy that we want to use, and then we this function is called if the authentication is successful. Okay, this is something that we will see better next week. So how we want to store the user information on the client side. We can store them in a context, in a state. We will see better the next week. And up to now, what we have seen is related to the authentication. This is for the authorization. So what we want to do is to protect some routes. So we can say that this function can be done by this query can be done by user A, user B, or what do we want to say that maybe some queries can be done only if the user is authenticated. There are some that all the user can do, so if they are authenticated or not, and some only if the user is authenticated. For example, if we think about our application, we may want that all the user can see all the asked questions, while only the authenticated user can access the question, modify the answers, add answers, and so on. Up to now, what we did, you have just allowed the cross-origin to all the origins. At the end, what we should do is also to specify the origin that we want to accept, and if we want to authenticate it, and we should just modify this piece on the course configuration. Okay, so how can we authorize? So how can we define which routes are protected, which APIs can be done by only authenticated user? We can use rec.isAuthenticated at the beginning of all callback. Or we can use a middleware inside to put between the root and the callback function. We can define this function that is a middleware, so in which we verify if a user is a logged user, and if the request is authenticated, we can return the next middleware, so or the callback. Otherwise, we return a status in which we just use a message in which we just say that the user is not authenticated. Then when we define our route, we define, for example, here the get, in which we add this additional middleware and so on. So if we receive an API with this route, we check if the user is logged in. If the user is not logged in, we reject this, otherwise we go on. And then for the logout is quite simple. We just define the API to logout and then send the request to logout. At this point, the server should delete the session ID, so with the cookie, with the related information that it just saved. Okay, I don't know what time is it. Okay, we can see this is a small here, a small function here to too much. Okay. Here what I did is to generate a salt and create the hashed password that we should retrieve from the server and then use password in a very easy way. What I wanted to show is how the crypto.script works. So we pass the password and the salt, and again the salt should be a random string, and then we check if the two if the two strings are equal. So let's see. Again, this was a test that I was doing yesterday. And if we modify, for example, here, the password is not correct, what we obtain is false. So if the user doesn't insert the correct password, the verification will fail as soon the user is not authenticated. How we generate in this case, since we don't perform the registration of the user, how we can generate our beautiful hashed password to store in the database. We can use these two beautiful websites. Here we generate the salt in which we define how many digits we want to use and how many strings we want to define. In this example, there were 5. We copy and paste here, and here we insert our password that we want to use with the salt, and we generate the salted password that this is the one that will be stored on the server side in the database. Okay, questions? Nice. We can have 15 minutes break. Okay.